Okay, we'll continue with our discussion of problems. In the last class, there was this homework problem, problem 36. There were two others also. Have you guys attempted this problem?
Yes, sir.
What are you getting?
Sir, root over 98.
That is correct. So basically 7 root 2.
Yes,
How do you get this answer?
Sir, let 2 to the power
yes,
of
sir,
a
I got
plus
the
1.
same answer.
Sir,
One of you tell me what you did.
Sir, let 2 to the power of a plus 1 plus half to the power of a minus 1 is equal to k. मैंने बोथ साइड को स्क्वायर कर दिया, तो मैं ये हुआ कि 2 to the power of 2a plus 2 plus half to the power of 2a minus 2 is equal to k square minus 8. अब मैंने k square minus 8 को b मान लिया, तो ये हुआ कि 2 to the power of 2a plus 2 plus half to the power of 2a minus 2 is equal to b. अब मैंने फिर दोनों साइड को स्क्वायर कर दिया, तो ये हुआ कि 2 to the power of 4a plus 4 plus half to the power of 4a minus 4 is equal to b square minus 32. अब मैंने दोनों साइड से 4 कॉमन ले लिया, तो ये हुआ कि 2 to the power of 4 to the power of 2a plus 1 plus 1 by 4 to the power of 2a minus 1 is equal to b square minus 32 by 4. और यहाँ से मैं b का b is equal to 90 ये गेन किया, तो इससे k square minus 8 equal to 90 आ गया, और k square is equal to 98 और k is equal to root over 98.
Okay.
Sir, I did a different method. So first of all, like 4 to the power 2a plus 1, I wrote it as 4 into 16 to the power a. And this second part I wrote it as 4 into 4 upon 16 to the power a is equal to 2017. So 4 I took common and put it into 16. Yeah, 1 upon 16 to the power a is equal to 217 upon 4. So I added 2 to both the sides. So it became 4a plus 1 by 4a
whole square.
Yeah, yes, sir. Is equal to 2025 by 4. So it's like 4a plus 1 upon 4a is equal to 45 upon 2. And then I repeated the method, like added 2 to both the side. So
49 by 2.
Yes, sir. So it became 49 by 2 is equal to 2 की power a plus 1 by 2 की power a. So in this term, it's just 2 into 2 की power a plus 1 upon 2 की power a.
It is 2 into 7 by root 2 basically.
Yes, sir.
Fine. It's correct. Both the methods are correct. You can do it with whichever method. It's fine. Let's move on to problem 37. Problem 37 was the number theory one, right?
Yes, sir. M की power 4 plus n square is equal to 2017 to the power 2017.
Prove that there are integers m and n such that m power 4 plus n square is equal to 2017 to the power 2017. Any ideas here? Here there is a small thing. The thing that you should notice is that on this side there are powers of 4 and 2, right? So on the other side, it seems like an odd number and all. Both are prime numbers, by the way, right? So odd to the power odd. It would be nice if you could get some squares and all here, right? Basically, you can say that you can write it as 2017 into 2017 to the power 2016, right?
Yes, sir.
What would be good is if we can get some squares and all on the right side also, because the left side is having m power 4 plus n square, right? So this is the main trick here in this problem. You have to think of, can we do sum of squares for 2017? 2017 is actually the sum of two squares. You can check it. It will be 9 square plus 44 square. This is the key idea here. Because if you can split it as a sum of squares, then the problem becomes a little doable. You can check the square of 44 and add 81 to it. You will get 2070. So what will happen here is m power 4 plus n square is equal to, you can write 2017 as 9 square plus 44 square, and outside you can write 2017 to the power 2016, right? So the right side you can simplify like this: 9 square into 2017 to the power 2016 plus 44 square into 2017 to the power 2016, right? And now if you think about it, 9 square is 3 to the power 4, right? And 2017 to the power 2016 is like saying 2017 to the power 504 whole to the power 4, right? Plus on this side, we
Yes.
can just say 44 into 2017 to the power 1008 whole square, right? Basically, you are easily getting 3 times 2017 to the power 504 whole to the power 4 plus 44 times 2017 to the power 1008 whole square, right? So this is a little tricky because this step you have to realize. Otherwise, you will not be able to do the split. The idea is this side is having powers 4 and 2. You need to create somehow the powers of 4 and 2 on the other side also, right? So that is what we have done here. And here our m becomes 3 into 2017 to the power 504. And our n becomes 44 into 2017 to the power 1008. Is it clear right now what is happening?
Yes, sir.
Yes, sir.
Okay. Let's go to the next one, which was problem 38. That was a system of equations. You have to solve in real numbers. The equations were x minus y is equal to 87. The second one was root over 2017 minus x plus root over 2018 minus y is equal to 22. Any solutions?
Yes, sir.
What did
Sir,
you get?
x comma y is equal to 1576 comma 1479 and 1936 comma 1849.
This is correct. Have you checked this whether it satisfies or not? 1576. Okay, so 76 and 20. It is not satisfying. I don't think it is satisfying. X minus y is not equal to 87. You are making a mistake, no? It is, you are doing 97 or something. Do you understand what I'm saying? This is not satisfying. How did you get the second answer?
सर ये क्वेश्चन बोला है कि x एंड y रियल नंबर है, तो मैंने लेट कर लिया कि x इज इक्वल टू a प्लस बी रूट सी एंड y इक्वल टू p प्लस बी रूट सी, बिकॉज x माइनस y एक इंटीजर है, तो x में जो अनरियल पार्ट होगा y पे भी वो अनरियल पार्ट होगा, तो मैंने उसको बी रूट सी मान लिया। अब
नहीं, 1 सेकेंड, why are you assuming? तुम ऐसा क्यों मान रहे हो कि वो irrational है? ऐसा क्यों मान रहे हो कि वो irrational नंबर है? समझ रहे हो मैं क्या बोल रहा हूँ?
यस सर।
ए प्लस बी रूट सी ऐसा मानने का जरूरत क्या है? एनीवे, उसके बाद क्या किए?
सर उसके बाद मैंने ऐसा लिखा कि तो वो जो सेकेंड इक्वेशन दिया हुआ है कि रूट ओवर 2017 माइनस ए माइनस बी रूट सी प्लस 2018 माइनस पी माइनस बी रूट सी इज इक्वल टू 22। अब इस दोनों का सम 22 तभी हो सकता है जब यहाँ पर मतलब मैं ये बोलना चाहती हूँ कि रूट ओवर ए प्लस बी रूट सी प्लस रूट ओवर ए माइनस बी रूट सी ये एक इंटीजर होता है। मतलब जब ए प्लस बी रूट सी ये और दूसरी तरफ डी प्लस बी रूट सी डी प्लस सी रूट डी ऐसा होता है तब इंटीजर नहीं हो सकता। तो इसलिए मैंने इसको ऐसा लिखा कि इस पे भी माइनस बी रूट सी है और इस पे भी माइनस बी रूट सी है। तो ये होगा कि 2017 माइनस ए इज इक्वल टू माइनस ऑफ 2018 प्लस पी। और इस पे और ये हुआ कि ए प्लस पी इज इक्वल टू 4035 और यहाँ से ए इज इक्वल टू 2061 एंड पी इज इक्वल टू 1974 आया। और इसके बाद मैंने वो जो 2017 माइनस ए इज इक्वल टू माइनस 44 आया और 2018 माइनस पी इज इक्वल टू 44 आया। और इसके बाद ऐसे सॉल्व किया कि माइनस बी रूट सी को के मान लिया और के माइनस 44 और के प्लस 44 ये दोनों इंटीजर होगा। तो
योर आंसर, तुम्हारा आंसर आ गया है लेकिन तरीका सही नहीं है। आराध्या, हैव यू ट्राइड एनीथिंग?
Yes, sir, I have a method. So, like, minus y is equal to 87 minus x. So, we can substitute it in the second equation. So, under root, we'll get under root 2017 minus x plus under root 2105 minus x is equal to 22. So now we can use the a square minus b square is equal to a minus b a plus b. So we can multiply it by under root
conjugate. You are
yes.
saying conjugate of this.
Yes, sir. We can multiply it by its conjugate.
Did you get the answer?
No, sir, I'm not able to get the answer. I guess I made a silly mistake.
Okay.
But the method gives the solution, I guess. Should give a solution.
Yeah, it should. The general way to solve it is not by assuming x is equal to a plus b root c and all. You don't have to do that. You are unnecessarily complicating your life. It is a real number. So you don't have to make assumptions about whether it is irrational or rational.
Yes, sir.
So what you have to do is try to simplify this equation somehow. And the best way to simplify this equation is multiply by conjugate directly.
Okay.
If you multiply by conjugate, what is the conjugate? We can say root over 2017 minus x minus root over 2018 minus y, right?
Yes, sir.
If you multiply both sides of this equation by this quantity,
yes, sir.
On the left hand side, we will get a square minus b square. So it will become 2017 minus x minus 2018 minus y, right?
Yes, sir.
On the right side, we will get 22 times root over 2017 minus x minus root over 2018 minus y, right?
Yes.
If you see here, this part is becoming basically minus 1 and plus y minus x, something like that, right?
Yes, sir.
So you're getting y minus x minus 1 is equal to 22 times
Yes.
of this thing. right?
Yes, sir.
And we already know y minus x is minus 87, right?
Yes, sir.
So this is minus 87 minus 1. So minus 88, right?
Yes, sir.
So this thing is becoming simply minus 4, right?
Yes, sir.
So this thing, if it is coming as minus 4, and you already know the conjugate of it is 22, it is super easy to solve. No.
Yes, sir.
You just add it, right? If you
Yes.
add it, you will cancel the y term. You will get twice of root over 2017 minus x is equal to 18. So root over 2017 minus x will be equal to 9. So square 2017 minus x will be equal to 81, right?
Yeah.
So x would be equal to 1936 then.
Sir, I noticed I made a mistake. I did it again, so I'm getting the answer by that method.
Right. So by the way, also notice that this is what we did in the previous question also. 2017 is 81 plus 1936 and 1936 is 44 square and this is
Yes.
9 square,
Yes.
right?
Huh.
Okay. Next question is this one, problem 39. This is consider the sequence of integers. Sequence of integers an, where n is greater than equal to 1, where a1 is equal to 2, a2 is equal to 4, a3 is greater than 0, and the condition is given a of n plus 2 is equal to a of n plus 1 square plus a of n square plus a of n minus 1 square plus n by 2 minus 3. And this is valid for n belonging to 2, 4, 6, and so on. And the other option is an square minus an minus 1 square plus an minus 2 square minus 1. And this case happens when n is equal to 3, 5, 7, all the odd numbers. Now they're saying if a6 is 2017, you have to find a3. Think about it. There is a rule that is given to find out a of n plus 2, right? And the data that you have been given is a1 is equal to 2, a2 is equal to 4, a3 is positive, and a6 is 2017. And we have to find a3. It's not very difficult. It looks complicated, but it's actually easy only. Is anybody getting any ideas?
Yes, sir. So we can first substitute A6 is equal to A5 square, A5 square plus A4 square.
We are
Plus
putting n is equal to 4 and applying this, right?
yes, sir.
Plus A3 square plus 2 minus 3.
Yes, sir.
So you're
And
getting
then
A6 is A5 square plus A4 square plus A3 square minus 1.
yes, sir. Then we can write A5 in terms of A2, A3 and A4.
A5 you will put n is 3 here and you will use this, right?
Yes, sir. So A3
Square minus A2 square
plus
plus A1 square minus 1, right?
yes. Yes, sir.
So A2 square and A1 square are already known.
Yeah.
So A5 is coming out to be A3 square minus 16 plus 4 minus 12, so minus 13.
Yeah. And in the same way we can write a equation for A4.
So write the equation for A4 then.
Yeah, so A4 is equal to A3. A3 whole square plus A2 whole square plus A1 whole square minus 2.
Whole square plus
A1
A1 whole
plus
square.
A2.
A4, so n is 2, so minus 2.
Yes.
And A2 and A1 are 16 and 4.
So
this
20,
is
19.
So this is plus 18 then, right?
Yeah. So we can substitute it in the equation we got first. Yeah. I was just
so you will get what equation now? 2017 is equal to A5 square. So that is A3 square minus 13 square plus A4 square. So A3 square plus 18 square plus A3 square minus 1.
So we can take A3 square as like x. So it will
You
be
get
easy.
x square minus 13 whole square plus x square plus 18 whole square plus x square is equal to 2018. Right? Something like this.
Yeah.
So this will become a fourth degree equation. It will become 2x power 4. you will get a minus 26 x square here and a plus 36 here. So it will be plus 10 plus 1. So plus 11 x square, right? And 169, 324 and minus 2018, right?
Yeah.
So 169 plus 324 is becoming 3 and 9 and 4. 493 minus 2018, right? So 507 and 118. So 1507 and 18. So 1525, right?
Huh.
This is my equation where x is a3.
Hmm.
So solve this equation and find x, no?
Fine.
You will be able to do it in multiple ways. You can factorize it, or you can solve it by taking x square as t and
Yep.
solving the quadratic.
Yeah, so the quadratic solution will be 2x square plus 21 and x square minus 25.
You'll get 2x square plus 61 and x square minus 25.
Yes, sir, sorry.
So since obviously it will be positive, so x square is equal to 25, right?
Yes.
And if x square is 25, x is plus or minus 5, but in the question they had said that a3 is greater than 0.
Huh.
So you have to take only the plus 5 answer, right?
Yes.
Okay, next question is this one. Find all integers n for which 81 n power 4 by 4 minus 2017 n square plus 81 is a prime. You have to find all the possible integers for which this thing is a prime number. the first thing that you should think of is whether n can be even or odd. You can quickly conclude that n cannot be odd. Why? Because then the first term will be a fraction. For first term to be an integer, n must be even, no?
Yes, sir.
Other terms are anyway going to be integers, but this term will be a rational number if n is odd, right?
Sir, n is 10.
Yeah, n is 10 is correct. Wow, what are you doing? How are you getting 10?
Sir, 81 n to the power of 4 by 4 is equal to 9n square by 2 whole square plus 81 is equal to 9 whole square माइनस मैं ये लिखा कि 2 इंटू 9 बाई 2 इंटू 9n स्क्वायर माइनस माइनस 2017 n स्क्वायर प्लस 81 n स्क्वायर. सो ये हुआ कि 9n स्क्वायर माइनस 2 माइनस n 9 का होल स्क्वायर माइनस 44 n का होल स्क्वायर. So
basically you are rewriting this expression like this, right?
yes sir and इसको a minus b into a plus b फॉर्म पे तोड़ा तो जो a माइनस बी है वो स्मॉल टर्म है तो उसको मैं 1 लिख दिया क्योंकि ये प्राइम है तो इससे इनका वैल्यू 10 आया.
Basically, if you factorize this expression, it is coming like this, right? And then if this number is a prime, then it is being written as a product of two integers. So one of them has to be 1 and one of them has to be n, the prime number p, right? Aradhya, are you understanding? Since this whole expression has been written as a product of two numbers and it is a prime number, so the lower one must be 1, right?
Yes, sir.
So you can say n square and 9n square minus 2 minus 44n minus 9 is equal to 1. So you will get a quadratic equation that you can solve now. Right? Correct. So that is a very good solution. And from here you will get n is equal to 10. I hope everyone else has understood what has happened. If you check n is equal to 10, if you put here, you will get a prime number which is 881. You can check that also. Is it clear for everyone?
Yes, sir.
Okay, problem 41. Okay, you have to solve in real numbers. The equation cube root of 1350x cube plus 2017 plus 8 by x cube is equal to 15x square. This equation. these are the three problems that are homework. Problem 41, we can discuss now also if anybody can solve it right now. Problem 42 is a circle problem. Quadrilateral ABCD is inscribed in a circle of area 2017 pi. Three sides are given, AB, BC, CD. You have to find the fourth side. And problem 43 is a trigonometry problem. A is an angle between 0 to pi such that 1 by 3 sine A minus 1 by 7 cos A is equal to 1 by 2017. If the modulus of tan A is m by n, where m and n are positive and co-prime integers, which means they are relatively prime, find m plus n. You don't have to try to finish it right away. Think of these three problems as homework. Try to do it by tomorrow. Okay. If anybody is getting anything in problem 41, then tell me. Okay. Keep trying. Is someone saying something?
X cube is equal to 1 is a root.
What?
X cube equal to 1.
So what is your x? X is 1.
Yes.
How did you get that?
I took x cube equal to t whole cube both the sides.
Okay.
1350 t plus 2017 plus 8 by t is equal to 3375 t for t square.
Hmm.
And following that, I got a cubic polynomial wherein I put t equal to 1 and I got and it solved.
So the cubic polynomial had a root for t is equal to 1.
Sir?
For that cubic, you were able to get a factor t minus 1.
Yes, sir.
Fine, that's correct. You have to simplify it a little bit. There are slightly cleverer ways to do it also, but whatever you have done is correct. It's fine. We will discuss any other solutions if someone comes up with a different solutions tomorrow. But try 42, 43 also. Okay. These three questions are homework. Tomorrow's class will begin with the discussion for these three, and then we'll go ahead to more problems.
Thank you,
Okay.
sir. Bye, sir.
Bye. That's all for now.
Bye, sir.
Bye.